Okay, guys, today we're going to be talking about experimental probability. We've been talking about probability, and you didn't know it, but what you were learning was theoretical probability. This is now going to be experimental probability, which is a little bit different. So experimental probability is something that you can actually estimate based on events that have happened in an actual, what I call an experiment. So let's take basketball, for example. What's the probability that you're going to make a free throw? Okay, now I'm going to try to pull up some tools here so I can write on this. And the probability that you make a free throw would be you're either going to make it or you're going to miss it. And because there's two things that can happen, then you're going to do one of those two things. So in theory, or theoretical probability says that the probability of you making a free throw shot would be 1/2. But we all know that some people are better at free throw shooting than other people, and they can actually increase this if they're better, or they could actually decrease this probability if they're not as good based on their skill. So experimental probability is something that would be based on what actually happens in an event. So if a player shoots a foul shot whenever they get fouled, and that person has a 73% free throw average right here, you can probably predict that that person's going to make their free throws as opposed to someone who had maybe a 40% average. This person right is way more likely to make theirs than the 40%. So let's talk about experimental probability. It's going to be based on doing an experiment multiple times, okay? The number of times you do an experiment is going to be called the trials, okay? That's the repetition. The number of times you do it would be the number of trials. And the sample space is a list of all the possible outcomes, okay? So that's all the possible outcomes. I'm having a hard time with this here. Okay, so the experimental probability of an event is the ratio, and you should all know by now that ratios are fractions. We're still dealing with fractions here, of the number of times an event occurs to the number of trials. So that's the fraction we're going to be looking for here. The number of times an event occurs compared to the number of trials. Oh, I don't want to keep those notations, and I'm going to go to this. Okay, so let's say you're on the St. Henry basketball court and you are shooting free throws, and we're looking at what's the probability that you are going to make a free throw shot, okay? So what's going to happen when you shoot the ball? You're either going to make it or you're going to miss it. So there are two things that can happen, and only one of those two things that are going to happen. So the theoretical probability of making it is going to be 1/2. But the experimental probability is kind of where someone's skill might come into play. So let's say you actually go outside and you shoot basket, okay? And you are going to shoot, let's say you're going to shoot 10 free throws. And let's say you only make 3 of those. Then your probability is going to be 3/10, which is actually less than 1/2, which is what would happen in theory, okay? So you could actually go out and perform this experiment. How many free throws could you make out of 10? And you could compare it to the theoretical probability that you should make 1/2. We're going to do a number cube. So I've got a number cube here, and it's or a dice roller. And let's talk about probability of rolling a 6? Okay. Well, in theory, okay, so I'm going to call this theoretical probability. In theory, since there are 6 numbers on a number cube, 1 out of 6 is going to be the theoretical probability. Okay. The experimental probability, though, might be different, even though there's no skill here. Let's actually roll this 6 times, and we're going to put tally in the make column if we make it, and we're going to put it in the miss column if we miss getting a 6. Okay. So let's roll the dice. Roll number 1, we got a 3, so we missed. Roll number 2, we got a 5, so we missed. Roll number 3, we got a 1, so we missed. Number 4, we got a 2, so we missed. A 6, oh, we made the 6, so we make it. And a 5, we miss it. So you can see here that our experimental probability actually matched the theoretical probability. And that won't always happen, okay? Usually when something is fair, the experimental probability will actually be equal to the theoretical probability. So I want you to try this experimental probability activity for today and report your findings to me.